fact that, you know, we have a product called External System Reporter, which involves an external server for reporting. Well, you don't have that license. And there are ways you can get reports within Management Console, the legacy GUI we've talked about all week. But since at Bank of America, you're going to be using the GUI SSMC, you're going to be using the reports within SSMC. All right. So remember a couple of points in terms of that. You know, we have that database out there that's carved out of your SSD disk, essentially, called the .sr data file that, you know, has a retention period, but essentially it keeps what we refer to as the high-res data, the daily data, and the hourly data. Samples, I'm sorry, the samples. And there's kind of a rolling database for all of those samples. Remember, now you're going to be able to increase the size, the default size of the .sr data. But essentially, we have that database out there that holds the performance metrics, the capacity metrics, if you will. And we pull from that database from the reports. It's pretty easy to get into the reports. You actually, remember, have to start off with one of our predefined templates. You use the template to create a report, and then you just basically add your metrics, your objects. Like, for example, there are reports where you can go out and look at, you know, ports. So you can drill down into certain ports. You can drill down into disks. So you can drill down using the object selection, certain disks or certain types of disks. CPGs, you know, you can drill down their capacity CPG reports where you can go in and look at certain CPGs or all of your CPGs, volumes, etc. So, and there are some couple of real-time reports. I'm going to show you one today. I'm going to use one today. But some of the reports are hourly. You can do what are called hourly reports, daily or high-res reports. By default, high-res, the interval is 5 minutes. Historical reports. Save the reports as a PDF, export them, email. So you got the reports you can use for troubleshooting, capacity planning, and so on. But also remember, you've got a series of CLI commands you can use for performance, right? Like the historical stat commands, stat port, stat PD, the historical hist commands, hist PD, hist LD. And then about 3 years ago when we came out with that .sr data database, we introduced a series of what we now call the SR commands, the system reporter commands. SR stat port, SR stat PD, SR stat VLUN, SR hist VLUN. So you've got those CLI commands. Remember those because from my teachers at Bank of America, you know, I was led to believe that the majority of your admin work will be done through the GUI SSMC. So you won't be using a lot of the CLI day to day anyway, in terms of adding hosts and CPGs and so on. But you know, remember those stat commands and those SR commands from a performance troubleshooting. You probably want to remember those at least. One other thing I want to point out, since I'm thinking about this, you know, in my teachings, I've been, you know, this is my 4th teach for Bank of America. It might be my last, but I'm not sure. So one of the things I do know about your environment is, at least at this point, it's pretty fixed. In other words, we know you have 10 cages total. You have 4 controllers. You have 240 SSDs. When your 7440 was, you know, brought online, some CPGs were created, volumes created with default CPGs and set sizes and RAID levels and so on. So I do believe your environment is fairly static. Now, that's not to say that you may not have to go out there, or somebody within your organization might have to go out there and create CPGs, create a snapshot, export, do a DO tune on a volume. So that's why we're going over this. You're taking this class so you know kind of what goes, how this array works. So, and I don't know particularly about your day-to-day job description. I think though your environment is pretty static at this point, but I do think that you are looking at or at least looking at the possibility of, in the next year, maybe two, of purchasing one of our newer models, the 8000. And here in a few minutes, by the end of the day, I'm going to give you a little bit of the 8000, talk a little bit about the 8000 series. So in any event, you've got the stat commands and the on-node system report. And then we talked about remote copy. I don't think currently you're remotely replicating, but the remote copy feature allows us to migrate data from one array to another, pretty straightforward. But you can replicate using the RCIP ports, the 1 gig Ethernet ports, the RCFC ports. Normally we use the FC ports, the remote configured as what we call RCFC ports for shorter distances. So we talked about the concept of a remote copy group, and you can essentially replicate, synchronously, periodic asynchronously, which uses those snapshots. We're going to come out with a new mode called asynchronous streaming, synchronous long distance, which involves 3 arrays. So we talked about the different modes of the replication. And remember, we talked about the different states when they're in a normal state. What happens if the local array goes down or has a problem with the remote site array? You stop an RCG, what happens? Well, we take snapshots normally at the local site. So, we talked about failover scenarios. So the goal there was to give you an overview of the, the concept behind remote copy, how it works. Administratively, it's not that hard to do. How many of you did the lab yesterday where you eventually created some volumes, replicated to the remote site array? Nobody interested? Well, okay, well, that's good. But, we went over the concept. So a remote copy. And you're going to have some time today. We're probably, like I said earlier, we're going to probably have a short day today. So you'll have some time in the afternoon if you decide to go back and play with remote copy if you want to. So we have a few things to talk about today. And one of the things I just mentioned before we have 2 topics. We're really going to wind up talking about today our main topics. Let me just write this out here. We're going to talk about what's called priority optimization and quality of service. Whoops, cannot type. QoS. And then we're going to talk about, which won't take too long, and we're going to talk about data migration. And migration means essentially migrating from one 3-part to another. So like, for example, if you do purchase a new 8000 model at some point next couple of years, you might want to migrate at least some of your data off your 7440 to your new 8000. That's a possibility. We use a feature called peer motion. And also, I do know you work with EMC disk arrays. So you can use a tool called online import to migrate from an EMC to a 3-part. Now, at this point, I believe the majority of your data has been migrated off of the EMC disk array. But we'll talk a little bit about data migration. But before we get into these 2 main topics I want to talk about today, I just mentioned that we're coming out with a new 8000 series, a new Give me just a second to bring something into the classroom. I just mentioned, I mentioned the other day, we came out with a couple of new hardware models, what's called the 20,000 series and the 8,000 series. And at some point, when I was doing some of my teaches for Bank of America, somebody told me to go over the 8,000 series a little bit, since you're considering purchasing one. And this actually won't take too long to discuss. It'll probably take 5-10 minutes. But I want to give you a little bit of an overview of the new, fairly new 8,000 model. Okay. And this is actually zipped up in one of the zip files I put in your in that handout section. So we just recently came out in the past couple of months with a new model called the 8000 series, and this is essentially a technological refresh of the 7000 series, and of course you have a 7440. So it's really, you look at it, it's basically the same. You've got controllers, expansion cages, and so on. But there are a couple of differences in the 8000 series, and I'll go over this pretty quickly. You know, on your 7440, the back end ports, those 6 gig SAS, well, in the 8000s, they're going to be 12 gig. And the fiber channel ports, all of the fiber channel ports on the 8000 are going to be 16 gig. You know, on your 7440, you've got a couple of 2 onboard fiber channel ports, which are 8 gig. So the onboards will be 16 gig. We came out with the new ASIC, which is quicker and it has a couple of features like persistent checksum, which is what they mentioned here. Actually, I'm sorry, I skipped around. We have a new feature called, a new ASIC called the Gen 5 ASIC. So we have a different PCI board and different processor. Then we came out with different models, the 8200, which is a 2-node model, the 8400, and the 8440, which is kind of the upgrade of your 7440. These three are what we call converged or hybrids, meaning you can have a mix of SSDs, FC, and nearlines. Then we come out with a new all-flash array called the 8450, which is a 4-node model. And this is basically the same slide we looked at earlier. You start with the base, your drive enclosures, rack, etc. I'll go over the possibilities of in that optional slot here. So I'll flip back to this. This is basically all the same. This is a picture. I'll give you some of the numbers here in a second. So if this is the guts of one of the controllers in the new 8000, some of the things, I won't go over all of this. We've got a beefier processors. They're 2.2 or 2.4 gigahertz processors in your controllers. We increased the cache counts in terms of data cache and control cache on the models. We got the new Gen 5 ASIC. Your ports, your fiber channel ports are 16 gig. And remember, in your 7000s and also in the 8000s, you have an optional slot. And we now have in the 8000, we have a 4-port 16 gig fiber channel card. Currently in your 7000s, in that optional slot, you have a 2-port 16 gig. So now we're offering a 4-port 16 gig fiber channel card. You have a couple of other options, a 2-port 10 gig DNA. This is used for the file persona option. And then you have I'm sorry, 2-port 10 gig CNA. This is used for iSCSI and FCOE. And then you have a couple of cards we support that add a couple of Ethernet cards for the file persona. And your back-end ports are 12 gig. This is all the same. There's not much. This is what they look like. You know, you still have node 0 and 1, 2 and 3 are a pair. I'm not going to go over all of the numbers here, all right? But this is a little bit of a chart. of the maximum number of disks. One thing to point out, you know, in your 7440 currently, you could only have 240 SSDs. But in our new 8440, in a 4-node model, you can have 480 SSDs. So the new 8440 supports twice the number of disks as the 7440. You still have, you know, 38 expansion cages on the 8440. And this is pretty much the same node slot and port. There are a couple of differences on the controller on this 8000 versus the 7000. And, you know, here in this optional HBA, as I mentioned, we support a 4-port 16 gig fiber channel card, a 2-port 10 gig. This is essentially the same in a couple of Ethernet cards. But the real differences here, you know, are these two on your 7040. These back end disk ports are 6 gig. On the 8000s, they're going to be 12 gig. And on the expansion cages, the back end ports are 12 gig versus 6. And these onboard fiber channel cards are 16 gig versus 8 gig on your 7440. So this is pretty much the same, you know, still have NSP. The only other thing I noticed, and I don't know why they did this, off here to the right, we switched the RCIP ports. In other words, on your 7440, your RCIP port is on the top and the management port is on the bottom. They switched them for some reason. And this is still a 1 gig Ethernet port, which will be able to be used for the file persona feature as well. For file persona connectivity, you can use this port or configure this port, or you have to get one of these 1 gig or 10 gig Ethernet adapter cards for the physical connectivity. So, you know, that's pretty much the same. We still support the 2 expansion cages, small form factor and large form factor. You know, one of the differences though in the new 8000 expansion cages, you know, in the back of your 7440, the ports on the IFCs in the back, if this is the back of one of your small form factor expansion cages in your 7440, these ports are 6 gig, they're 12 gig. You know, so, and here they list the disks. We support just like in your 7000s, we're supporting a close to 4 terabyte SSD. You know, one of the questions, and I'll just throw this out to you, you may not find this interesting, but in one of my teaches in New York for Bank of America, one of the students asked me, they said, well, we're all SSDs, right? We're all SSDs. All of our disks are SSDs. Now, you know, we have a model called 7450. That's an all SSD array. You guys decided to do a 7440, which basically could, you know, which you populate with all SSDs, but could have a mix of, which could have a mix of FC nearline and SSDs. Now, so somebody asked me, well, why did we buy this 7440? Why didn't we buy a 7450? If we're going to use all SSDs, why didn't we buy the 7450? Well, the short answer is I really wasn't there and involved in your business decision as why you decided to do this. But one consideration is, you know, down the line, you might be able to add additional capacity. But, you know, one thing I want to point out, we don't support in the 7450 or the 8450 those 4 terabyte SSDs. Okay, so that was probably your decision. Get the 7440 converged. That's what I'm thinking. You said, well, we want the bigger disks. So you went with the 7440 instead of a 7450. But I'm guessing We do support a 3.84 15K disk. So this is a large form factor expansion cage. This is all the same. This is all the same. We do have a couple of options here in terms of the back end, new option for the back end cabling. These are just some pictures. So here's a comparison of the 7000. Here's the highlights. New processor, new ASIC, different bus architecture. The ports went from 8 to 16. So now you have 24 16 gig fiber channel ports. The raw capacity numbers overall went up, double for the SSD. So that's something to be aware of. If you do wind up getting the new array. Okay. So let's talk about the next topic, what's called quality of service and priority optimization. Okay. And let me tee up a little example here. Let's say these represent your 4 controllers down here on your 7440. These are your 4 controllers, 0, 1, 2, and 3. And let's say you have a couple of hosts. I'm going to make this a pretty simple explanation. Let's say these blue squares up here represent a couple of hosts. And each host has a couple of host bus adapters in it. And each host is connected to a couple of switches here in blue. These are some switches. And then each switch is connected to a couple of fiber channel ports. I'm not drawing this to scale, but you get the idea. So these 2 hosts are reading and writing to the volumes via the same controllers. All right. So they're competing for the resources. They're reading and writing to the same front end ports. They're competing for the cache of these controllers, the ASIC, the resources. Well, let's say this host off here to the left. And let's keep this simple. Let's say both hosts have 1 volume exported to them. This host off to the left has a volume called VV1 exported to it. And this one has a volume here in gray exported called VV2. Let's say this host off to the left, the purple host with this 1 volume, you're using this volume for very business critical application, maybe some sort of database. And performance is important, right? Where performance is key. So this is a higher priority. This is a high priority application. This host off to the right here, this volume exported to it VV2 isn't as high as prior. Maybe you're just using this for testing or backup or development. So this is a lower priority application over here. But both of these hosts are reading and writing to these volumes here via the same front-end host interfacing ports using the same controllers, cache, et cetera, et cetera. All right. Let's say you do some troubleshooting or you do some of like the stat VLAN commands or look at a report and you see this lower priority application spike. So let's say normally this app sits at around 6,000 IOPS. But all of a sudden it spikes, it goes up to about, for whatever reason, about 30,000 IOPS. So it spikes. And when it spikes, it's going to impact your higher priority application over here, right? It's possible, you know, monopolizing more cache, more resources, the array. So what you might want to use or you decide or consider using is a feature called priority optimization and quality of service, QoS. QoS is setting up what we refer to as the rules. So what we might want to do for consistency's sake and so on is for this, maybe for this lower priority application, we're going to set up what we call a quality of service rule. We can. And I'll show you how this is done, but we're going to set up what's called a rule, and we can say, okay, the max IOPS, we never want this application to go above, you know, 10,000 IOPS. Okay, we want to cap it off. Because if this spikes over here, this could impact this higher priority application. So normally what we want to do is oftentimes use priority optimization on maybe our lower priority apps so they don't impact my higher priority apps. Now we're going to do all this at the volume level, and I'll show you how it's implemented. We're going to use volume sets and rules and so on. There are a number of other things I've got to talk about here, and talk about how it works. But, you know, at the end of the day, here, I like to say that priority optimization and quality of service is a front-end mechanism. All right. So in other words, let's say this DBA over here for this database comes to you today and says, well, man, you know, yesterday everything was fine performance-wise. Today I'm taking a big performance hit. You do some troubleshooting as an admin. First of all, it may not be the array. The array may not be the bottleneck, but let's assume you do some troubleshooting. You say, okay, well, maybe the issue here for this database, why it's taking a performance hit today, is it's a back-end thing. In other words, maybe when I say back-end, I mean the disks. This won't apply to you, but maybe this database from what some of my customers might be carved out of 10K FC disks, and it would get better performance if we did a DO tune to tune it to SSD capacity. All right. Maybe this application is doing a lot of random reads, and the bottleneck or the solution might be adding adaptive flash cache on the back end. So, you know, priority optimization isn't a cure-all for every performance-related situation. You know, if you do some troubleshooting and basically say, well, man, you know, it's a front-end issue, because this app is really kind of reading and writing, monopolizing the resources of the array, etc. You know, priority optimization is going to essentially rein in. So you know, from the front end, this is monopolizing the front end resources. It's going to cap it off. So the point I'm trying to make here is this: this isn't a solution if it's a back end problem. If you don't have enough disks, you have the, you know, you have volumes carved out of the wrong disks. Maybe you have to do DO tunes or change the RAID level from a RAID 6 to a RAID 1 because you're getting a back-end penalty. Maybe adaptive flash cache in a hybrid array might be a back-end solution. So this isn't intended to fix every problem. It's kind of a front-end sort of solution. So we'll talk about the advantages, PO, QoS. And when you hear that the feature is called priority optimization, you want to give priority to certain volumes, applications, if you will, over others. And we're going to implement this through what we call QoS rules. So you hear the terms PO, QoS kind of used together, which talk about the performance ramifications of PO. And you can work with PO using SSMC in the command line. And there's some alerts. We talked about alerts yesterday. There's some applicable alerts you can set up for priority optimization. There's a report you can look at for PO as well. A little bit of an introduction. This is kind of what I just talked about. Let's look at this picture over here. So if you've got application A, application B, app C here, you want to possibly set maximums. And I'll show you how this works. You also might want to set minimum goals. So you can set a max, but a minimum. You don't want certain apps to fall below a certain floor, if you will. So the max means you don't want it to go above a certain ceiling. A minimum for a certain app, but which is a goal, not a guaranteed. And I'll get into this. You can set minimums and maximums. And I'm also going to talk about what's called the all others rule. Let's say you have some priority optimization set up for some volumes of some apps. And then you have things that aren't even set up for quality of service. You might set up what's called a generic all others rule that doesn't have explicit rules set up. Okay, and I'll talk about all of this, trust me. So let's read this. If all resources on your array were unlimited, meaning you had all the cache in the world, all the controllers, all the ports in the world, all the ASICs in the world, all the disks in the world, you might be okay. You had all the money in the world, but since storage resources are limited, cost money, you might have periods of contention that might disrupt, business operations unpredictably. You want consistent, consistent application consistency levels. So without storage QoS, hot or active data could use more resources. So in other words, in my example, right, this testing application spiked up. It got hot. So the hot application might, starve other maybe more performance critical apps. So now we're going to get into the third bullet item here. Higher priority apps could fall below, basically take a performance hit. And we might want to set minimums and maximums for our lower priorities, set maximums. You might even set some maximums just in general for consistency purposes. And I'm also going to talk about a minimum. Now, why would you want to use quality of service? Let's read this over here to the left. You'll hear the term, sometimes you'll hear the term noisy neighbors. Noisy neighbors might disrupt cloud and enterprise storage delivery. When an app or VM spikes up its performance utilization, and that leaves less controller caching, or basically cache, and fewer flash resources on the front end. For other applications, customers feel the adverse effects of a noisy neighbor. This limitation or this situation is a major reason why it's difficult for storage cloud providers to provide consistent multi-tenancy environment using traditional arrays that don't have something like we have with PO/QoS. Now, by the way, you need a license to do priority optimization, and you do have the license for PO. This bullet item here, this blue circle, they're saying, oftentimes people think, well, I'll just throw more disks at the problem. If I got a performance issue, let me throw more disks at the problem. Let me throw more cache at the problem. Let me throw more, if my host or my application at the host level, if you will, is seeing performance, a performance hit or performance degradation, maybe I'll just add more paths from the host to the array. Adding more paths might help, but it's, sometimes these things like adding more cache, which are expensive, adding more controllers, you can't, but some of my customers might have to take a 2-node model to a 4-node model. So, one thing I want to point out here is when I talk about front end, I mean usually from the host to the front end ports, the fiber channel ports on the three part controllers, plus the cache at the controller level. Back end is disk interfacing ports. So, one other, it may not, remember my scenario here where my DBA came to me and said, man, I'm taking a performance hit today. Maybe it's not even the array's issue per se. Maybe their application considerations, you've got queue depths at the HBA level. There are things at the host level. You've got cache, which might be the bottleneck. sometimes people say, let me just add a couple of HBAs here and add a number of paths here. So, but that's not always the solution. But the point I'm trying to make here is if it's a front end issue, it may not be 3-par front end, but so here I've got a little speed sign. We want to set mins max. Here's some use cases. This is the one I just basically mentioned. You might want to prioritize mission and business critical workloads over workloads that like testing, developments, backups. You want to accommodate bursts in workloads, spikes in workloads. So, for certain apps, particularly your lower priority, less critical apps, you don't want them spiking up and going rogue. You just want consistent expectation levels, performance expectation levels. You want to manage periodic variations in workloads, again, kind of when things go rogue, certain apps go rogue or spike, improve the cloud experience. And there's some, there is a use case for PO for things like remote copy. If you think about it, let's say you have at your local site, you have a volume or volumes that you're replicating across the intersite links using remote copy. And you kind of want to control the replication traffic across the links. Well, you could actually implement, PO on the front end, kind of cap off the actual writes from the host to the local site array, cap it off or rein it in. So it's going to impact your replication traffic or minimize or slow down your replication traffic across your link. We haven't talked about peer motion, but it has a place as well with peer motion. It's a couple of things here. It's pretty easy to set up, monitor, troubleshoot. Works on all the models, your 7440 and the new models. When you set those maximums, remember my example here, I set a max in IOPS. I want to say, okay, no more than 10,000 IOPS. But when you set a maximum on a rule, you can set it in terms of IOPS or bandwidth or both. So let me I'll talk about both of these. You'll also be able to set what we call minimum goals, latency goals, priority. And what's key here kind of administratively is we're going to have to take the volume or volumes we want to set the rules on and put them in a volume set. Once you get them in volume sets, you can set up the rules and then from there enable them, disable them, and modify them, etc., using SSMC or the command line. You're not looking at installing any host agents on the host or doing any partitioning or creating any special CPGs. For the volumes you want to use PO on, you have to put them in a volume set. And you do need a license. Over here, they're just kind of talking about, if you look at the picture, as I mentioned, they're using the term tenants here. Let's say I have certain application or tenant 1 and tenant 2 here. These are two different tenants, apps, whatever you want to call them. So what they're showing you here is with these two different tenants, you're going to set maximums, and you can set maximums in IOPS or bandwidth. The bandwidth limit or maximum is set in KBs. So what they're saying here with these speedometers from the old cars, in tenant 1, we can set a limit in IOPS and bandwidth. Down here, this is a different application or tenant. We can set the bandwidth or IOPS limits max, but they're different here, right, for both tenants. So both apps, whatever you want to call them, apps, tenants, whatever. Now, here's a little bit of an example. And I want us to look at the picture over here. All right. So I really want to focus from this line up, black line up over here. So you've got array, you're going to set up priority optimization on the front end. Now let's say, follow the red bouncing ball here. You've got application 1 or tenant 1, application 2, or an application 3. Let's say you've got these 3 apps, which are the basis of them are volumes, right, exported to hosts over here. And let's say application 1 here is this black volume. I've got this black volume exported to host, and this is running application 1. All right. Now application 2 here is, or tenant 2 here, are these 2 volumes. Maybe I've got a database, these 2 volumes exported to a host. I've got a database spanning these 2 volumes. Right, so that's application 2 or tenant 2, if you will. Then application 3 here, or tenant 3, if you will, are these 3 red volumes. Maybe these 3 red volumes are exported to a host, and there may be multiple different hosts, but this represents application 3, the red volumes. Application 3, red, blue 2, app 1 is black. Now, what they're gonna do here is they want to say, okay, for application 1, application 2, and application 3, they're going to we're going to set maxes to be 10,000 IOPS. That's what they're going to do. We're going to set max. Okay. Now, what you're first going to have to do to implement the rules is set up what we have to put them in volume set. So app 1, app 2, and app 3. You're going to do this. The first administrative thing you've got to do is put them in a volume set. Even though this is one volume, the black volume app 1 up here, we got to put it in a volume set. Once you put them in volume sets, then you can set your limits. Okay, so that's what we're going to do, set limits here. Now, what they're showing you in this example is essentially what's called an overlap, because we want to cap off app 1, 2, and 3 to be 10,000 IOPS. But what they're going to wind up doing here is the first app, which is the black volume here, is app 1. Remember, app 2 are my 2 blue volumes. And then app 3 are represented with the 3 red volumes, right? We're going to wind up putting these in a volume set. And we're going to set a max IOPS value to be 20,000. So here's what we're doing here. We're saying, okay, app 1 can go up to 10,000, app 2 up to 10,000, app 3 up to 10,000. Could, but all 3 together could not exceed 20,000. This supersedes this. This is what we refer to as an overcommit or an overlap. Volumes can be a member of up to 8 volume sets. So these black, blue, and red volumes at this point are part of 2 volume sets, right? Like the blue is in this set, the black in this set. All right. So this is just an example, and then we're going to talk about what happens. Let's say this application here spikes up to 12,000. How does it work? You know, this application 1, it spikes up to 15,000 all of a sudden. So it's going over its max. All right. The other thing too is with this overlap situation here, let's say these 3 apps over here, app 1, 2, and 3, spiked up to 10,000. So remember, we capped all three of them off to 20,000. What's this going to get a higher priority? Well, maybe this application up here, the app 1, is a higher priority than app 2 or 3. So we might want to set this as a high priority. And app 3 down here might be the lowest priority. So we can set priorities as well, which I'll get into. Okay. Now, before I actually go into some of the rules, if you will, I want to kind of get set up a little demo for you. And I'm going to kind of push this out along the way here. Let me minimize some things you don't need to see. This is on my email. So I'm going to show you a little demo on how this works. And just to kind of set up my demo, I have a volume. Well, let me go to my hosts here. I'm going to go to my hosts here. Here's my host, Scully host. I'm going to change the view to export. And I have a volume called VV0 set up. It's the only volume exported to my host. It's 2 gig. All right. So I have a volume called VV.0 exported to my Windows host here. It's 2 gig. And just to show you that part, if I go into Windows Disk Manager, here's my volume. It's mounted as you know, the mount point is, the drive letter is I. So it's exported. Now, yesterday in one of your labs, if you did the lab on System Reporter, we used you used a tool called Iometer to generate a workload on your volumes. And I've done the same thing here. So on this volume, you see the first blue line here, total IOPS per second. It says 6116. So essentially, I have a workload, a mix of reads and writes, running against that volume at about 6,000 IOs per second. All right, 6,000 IOs per second. So remember that, it's 6,000 IOs per second. Now, for implementation of priority optimization and quality of service, the first thing I have to do is take that volume called VV.0. Let me make sure I have the right volume. Can't remember now. Volume that is exported is called VV.0. Here it is. VV.0. That's the one highlighted. And I need to put it in a volume set. Now, so it's possible, you know, for, let's say I have 10 applications and all 10 of them, I want to cap all 10 of them to have a certain IOPS. You can put more than one app in a, you know, in a volume set and set up the rule. But I mean, if it's one volume, 10 volumes, you have to first put it in a volume set. So I'm going to take this volume, click on Actions, add to a volume set. When you create a volume set, you give your volume set a name. I'm going to call it QoS PO set 1. All right. That's my volume set. And then oh, wait a second. I can't do this. I can't add it. I have to create a new set. Sorry. So let me go in Actions. Let me go into volume sets. So I have to create you can only add a volume to an existing volume set. So I need to create a volume set. So I create a brand volume QoS underscore PO underscore set 1. That's the name of my volume set, the array. And then I have to add the virtual volumes to the volume set. And I'll do a little filter up here. Remember, my volume is VV.0. I'm going to add it. And that's basically it. That's all I really have to do here to create the volume set. And there, in a second, I hope, up at the top, it looks like it's doing what it needs to. The light is green, or the square is green. Here's my volume set. So the first step you do is just create a volume set, put the volume or volumes in a volume set. All right. Now, one thing I want to point out here, watch what I'm going to do here. I'm pulling up the SSMC mega menu. Oops. See under storage optimization, there's a option there, a feature called adaptive optimization. In SSMC, with the newest release of SSMC, you can actually work with priority optimization within SSMC, creating your rules and so on. But just to kind of let you know, we're not running in our lab environment the most recent version of SSMC. So the lab, you're going to wind up doing, if you do it from the command, you're going to do it from the command line. All right, you're not going to use SSMC because you can, but since we're not on the latest release at the time, this release is called 2.1. We didn't support working with PO in quality in SSMC. But I just wanted to point that out because some of my demo I'm going to do here, I'm going to use the command line and a couple of other things to set it up. But, you know, I can put my volume in a volume set using SSMC, and I did that. Now, one other thing I want to do here, and this is kind of a lead into my demo I'm going to go into the reports area. And I'm going to create a new report. And what I'm going to do is select a template. And I'm going to do, see which template I'm using, the exported volume real-time statistics report. So this is a nice report to know about real-time stats on a volume. So I'm using what's called the exported volumes real-time stats template. And, you know, then I'll name my report. And then in the objects area, I'm going to do a filter by objects, add the objects. Do a little filter here. And remember my volume and my volume set that I'm going to set the rule up is called VV.0. In the list there, it's showing each path from the host to the volume. So remember the host, Scully host, has 4 paths to the volume VV0. So I'm just going to take all 4 paths and add them to my report. I'll keep the polling interval 5 seconds. And what I'm going to do here in my chart options, I'm just going to do a little chart saying, show me total IOPS. And I don't want to see bandwidth and service time. So I'm going to create a little report showing me basically every 5 seconds IOPS and service time for that volume. And here's the report. I just clicked on it. And you can see here in the report the total IOPS. Remember iometer, looks like it's going up and down a little bit, but iometer is running around 6,000. So you see the aggregate 6243. So the IOPS, you know, it's kind of going up and down a little bit, but it's sitting around 58, 60, 6,000 IOPS. So I've got the report up. Down at the bottom, it's showing me the total service time. The service time essentially means how long is it taking to service an IO request for this volume. And it's sitting, you know, at a 0.2, 0.22, kind of 0.2223. All right. So I just wanted to tee up the example. I've got a volume and a volume set. Iometer is running at about 6,000 IOPS per second. And I've got a little report running, okay? So to talk about how this works, I actually want to go to some interactive slides. So let's say this is my volume. It's exported to my host in my volume set, VV.0, okay? Now remember, the current IOPS that are coming in at about 6,000, right? Now, what I'm going to show you here in a few minutes, let me kind of show you this real quick. I want to jump to it. In SSMC, what you wind up doing to set up the rule, you click on, now this is what I told you you're not seeing in our release. You click on priority optimization, and you set up what's called a policy. you have a volume set, and you choose your volume set. And I want you to jump down here. Then you can set, there are a couple of things we want to go over here. But let's say you set up on that volume set an IOPS maximum. You can set an IOPS maximum. All right. So let's say, for example, current IOPS that are coming into this volume from the host is sitting at about 6,000 IOPS. And let's say you did have a rule set up and you said the max IOPS is, 20, let's just keep it fairly low, 12,000. You said, okay, I can't go over 12,000 IOPS. And currently it's sitting at 6,000, so it's under the limit, right? So what happens when a read or write comes in to the front end host interfacing ports on one of your controllers? Okay. When a read or write comes into the volume that you have set up into the volume set in the rule enabled, basically we check against all rules and see if there's what's called a breach. Basically a rule is broken. So like here, we're not breaching any rule. If I said my max is 12,000, I'm sitting at 6,000, no rule is breached, nothing special happens. So what happens is the read or write comes into the port. For a write, we'll mirror acknowledgement back to the host. A read, we might have to pull it off disk or maybe send it back to the host. But when no rule is breached, nothing happens. Nothing is different. So on the prior slide, they talk about how it works. Okay, what happens when a read or write comes in to a volume or volume setup with the rule implemented? One of three things can happen. If no rule is breached, the IO is passed on with nothing special, just like, if no rule is breached. So a couple of other things. One thing that could happen is you're not breaking any rules and everything else is the same. So two other points I want to mention here. What happens with priority optimization is it's comparing the current, say, IOPS to what your max is, what you've set up as your max. It doesn't distinguish between reads and writes. In other words, this max IOPS, if you set it to be 12,000, can be reads or writes. So you can't go out there and say, well, I want my max reads to be 5,000 and my max reads to be 7,000. As the reads and writes come in, we just compare reads and writes, the total. That's number one. And number two is, the other thing is, if we also check against the rule, what I like to say, at the port level. In other words, let's say a host here, this host here is sending a write request to this volume, to this. Remember, when a write comes in to a controller, it then hits the cache of the controller. It's written to the cache of the controller. Well, we actually check against the rule to see if it's breached before it hits cache. And that's nice. And I mean, that kind of would defeat the purpose. One of the goals here is you want to make sure that this write doesn't, go over a certain limit and monopolize your cache. So we actually look at the rule versus the current IOPS, say, pre-cache, what we call it the virtual volume level, before it hits cache. All right. So one thing that could happen is your no rule is breached and nothing special happens. But what happens, remember, let's say my current IOPS for this volume is, 6,000, and you set a max IOPS to be 12,000, right? But then all of a sudden, the current IOPS spikes up from 6,000 to 15,000. So it's going over the max IOPS limit you gave it. So we breached a rule. So if a rule is breached, like here, what winds up happening is the reads or write comes in. For the quality of service rule, okay, we start building a queue, an internal queue for the volume set / rule. We don't actually start queuing up the actual data. We queue up what we call the descriptions or the descriptors. As we start queuing up, And if you think about it, what will now happen if this host is sending IOPS greater, say, than the max you've given it, start queuing up, this host over here will see higher wait times, higher service times, higher latencies. But remember, that's the whole goal. We want it spiked up above the max, so we want to rein it in a little bit, right? Not a little bit. We want to make sure it doesn't go over 12,000. So this host will see higher wait times, service times, but that's what you want to do, right? So it doesn't impact other higher priority apps. Now, hopefully, once these hosts start seeing higher service times, wait times, hopefully at the HBA level, remember your host has HBAs in it, and, maybe the queues will start getting full here. Hopefully the host will start throttling the workload to slow things down. But if it doesn't and starts reading, writing, we're queuing up. And if the queue gets full, we can send a SCSI queue full message back to the host. And essentially the host will have to handle it. Essentially, won't be able to read and write. So what happens as you set caps and what we call rules, 3 things we say could happen. Basically, if no rules are breached, nothing special happens. But if the rule is breached, we start placing the IO requests, the descriptors, in a queue that's processed periodically. Okay. This prevents hosts that overissue IOs from overusing their quota or their max, adversely affecting the performance of the array. But when too many IOs are delayed, incoming IOs are rejected, and the SCSI queue full message response sent back to the host. That's how it works. Now, to configure priority optimization, again, in SSMC, you go into the priority optimization screens, you click on create priority optimization policy, the little button, you choose your array, and then you choose usually the target type virtual volume set, and then you choose the volume set. That you have the volume or volume set up and you're setting the rule. And then the default state is enabled. Later on, if you want to, you can go in and edit this and turn this off, rule off, and disable it, but the default is enabled, what's called the state of enabled. Now, so let's say you go in here and choose a volume set, and then down here, you are going to set up your prior optimization settings, all right? So I'm going to jump around here a little bit. So you can set what we call the IOPS settings. You can set a maximum. Like here they're setting what I can't tell from here. This is the volume set name is VVSet 145. I don't know if there's 1, 2, 20, 40 volumes in that volume set. But you can set what's called a maximum IOPS limit. So it can't exceed 24,000 IOPS. All right. So you can set what's called a maximum IOPS limit. You can also, in terms of limits, set what we call bandwidth limits, maximum bandwidth limits. Now notice this is expressed in KBs. So this is the max. So you could set, okay, max limit 24,000 IOPS. Here it's 28 and bandwidth limit of 28,000 KBs. So when you set the maximum, you can set it in IOPS or what we call bandwidth or both. You can do one or the other or both. All right. Now, when we just talked about like what happens when an IO comes in, remember if an IO comes in and it's breaching a rule, if you set both the max, IOPS max and the bandwidth max, if either one of these maxes is breached, so here, the volumes come in at, higher than 24,000 IOPS or higher than 28,000 KBs, then we start appropriately delaying or SCSI queue full, so one of these is breached. Okay. Now, for both IOPS and bandwidth, you can also set, you don't have to, you can also set what we call minimums in IOPS and bandwidth. So let's just deal with IOPS up here. So you might say for a maximum, okay, no more than 24,000 IOPS, cap it off. But your note here, it's an IOPS minimum goal. We want to make sure that IOPS at a minimum is 12,000. Now let's talk about this minimum. Let's talk about this minimum. Let's say this volume, there's just one volume in this volume set, this purple volume. All right. And let's say the current IOPS is sitting at about 16,000 IOPS. So it's coming in, and you say cap it off at 24. Well, it's below the limit, so that's fine. And you set this IOPS minimum goal. You're basically saying to the POQS algorithm, okay, I want to guarantee, actually, let me change my number here. Let's say the current IOPS is 8,000. So we're still, oops, that's not what I want to do. It's sitting at 8,000 IOPS. You say, okay, can't exceed 24,000. We're fine there. But you want to guarantee a minimum goal of 12,000 IOPS. So what if, like in this example, this volume or this application is only sitting at 8,000 and you say, okay, I want a minimum goal of 12,000. You know, but the host is just giving me 8,000. This minimum, you're saying, well, I want to make sure it's at least 12,000, but the host is just giving me 8,000. Let's talk about this minimum. This minimum is not a guaranteed minimum. All right, this is a goal. Now, what can happen, and we're going to talk about latency goals here as well. You can set what's called a latency goal for your QoS rule. Here it's 7 milliseconds, okay? So the algorithm, let's say you have number of volume sets set up, a number of rules set up, and so on. What could possibly happen is if you have all these competing factors in the competing QoS, I'm going to talk about the fact that the array keeps what's called a system busy level. And if the system gets too busy and it's trying to achieve all these latency goals for your rules and so on, it's possible that the system might start throttling certain workloads down to achieve certain goals. So if the array algorithm has to throttle this workload down in this volume set, if it does, this minimum means don't throttle it below this floor. In other words, if it has to throttle this workload, whatever's going on in this volume set, the workloads in this volume set, it has to, as a candidate, to be throttled down. Don't push it below a floor of 12,000 IOPS or 20,000 KBs. So these minimums are just floors. You won't let the algorithm, as it starts to throttle things, push it below a floor. All right. That's what the minimums are about. Now, you don't have to set minimums. All right. You don't have to set minimums when you set up a rule. You have to set up at least one maximum, either IOPS or bandwidth. That's all you need to do, one maximum. You don't have to set up minimums at all. Now, if you set up a minimum, you have to set up a maximum. So like here, if I set this IOPS minimum, I have to give it a maximum. If you set a minimum here, you have to give it the corresponding maximum. Now, if you want to give things a minimum, but not really, you have to give them a max. But if you don't really kind of want to max things out, you can put these max at 999999999. All right. Now, the other thing you can put, now this is another optional thing, is you can put a latency goal expressed in milliseconds. This is the goal, really service time. We keep track of service time. Remember I pulled up that report? I showed you that report, and my service time is about 0.23 milliseconds. So if you want, now this is optional as well, the algorithm for the volumes in this volume set will try to achieve a service time or latency goal and try and hit this latency goal, right? But on this screen, you really, the minimums and the latency goal are all optional. You have to put in, you can take all defaults, but you have to put in one maximum to set up the rule. Now, there are priorities as well. Remember those three apps, app 1, 2, and 3, I said you could set up a priority. And the default priority is normal, but you can do it high or low. I'll talk about setting priorities here in a few minutes, but this is how you set up a rule. You have to give it one max, and then you click on create. Once the volumes are in a volume set. Now, and then from there, in priority, in SSMC, you can see here they're in priority optimization. This is how you would create the rule. You can edit an existing rule, change the mins, max, anything. Disable it means just turn it off, and then you could enable it. Delete it just means delete the rule. Here's the name of the volume set. This is the name of the volume set. It's enabled. You get some specifics. It's just how it looks in SSMC. Now, when you create a rule, let me flip back here. When you click on Actions Create, when you're in the priority optimization, a few minutes ago, I showed you the target type was virtual volume set, and then you just chose the volume set. Let me flip back here. Target type virtual volume set, and the target name, you chose the volume set. There's another type of target called the system, and you set up what we refer to as the all others. We refer to this as the all others rule. Call this the all others rule. So let's say you have all these volume sets set up and quality of service rules set up for all of them and so on. It's a good, now this is not required either, but it's a good, we say it's a good idea to set up the system all others rule for all. This is a rule, let me just read this, a rule that affects all volumes in aggregate that do not have an explicit rule set up. It's customer defined, and they give you the low, you can't do things below this limit. So what we recommend you do is set up what's called the system all others rule for all volumes that don't have rules set up. And you can set IOPS and bandwidth maximums and particularly minimums. And you can actually give anything that's, well, you can give it a priority, high, low, or normal. So one of the things I'm getting ready to talk a little bit more about the algorithm, how it throttles workloads and how it just, if it needs to decide how to throttle workloads, how that works. But it's a good idea for anything that doesn't have an explicit rule set up to set up this all others rule, because then the algorithm essentially has everything on the array included in its algorithm as it decides how to handle what's called the system busy if the system gets really busy and it has to start throttling workloads. So this is how you work with it. So you can set maxes and mins. This is the maximum, has no dependencies on other controls. You can set mins, bandwidth, and IOPS, but you have to set the maximums. You can set the latency goal for the rule. This is the service time target the system will try to achieve for the workloads in a volume set. This control type, the latency goal, requires other rules in the system, including the all others, with min goals set as the latency goal algorithm needs direction on which workloads to possibly throttle. the order in which these could be throttles provided by the priority levels, which is the next segue, the precedence order for the array to throttle workloads to meet latency goals. And I'm going to talk about what's called the SLAs here in a minute. Now you can work with priority optimization as well from the command line. And you can use the commands setQoS, showQoS, statQoS, and srstatQoS. And I want to go over this real quick because in my demo, remember, I don't have the current release of SSMC. So what I'm going to do is I'm going to wind up setting a rule from the command line. And I'm going to say you can use setQoS, set your IOPS minimums, bandwidth mins and max, latency goals. You can do command showQoS. Show QoS and set QoS on and off, minus on, and clear to enable and disable your sets. So what I want to do here is I'm going to push out a share here, and you see my report is still running, exported volumes. So what I want to do here, I'm going to go into the command line and show you a few things from the command line. Okay, so a couple of things. I'm going to do show VVSet just to show you, remember my volume set. My volume set is called QoSPO underscore set. That's my volume set. So what I'm going to do here is use the CLI command to set up a rule. I'm going to do set QoS. This is how you set up a QoS rule for the volume set. I'm going to use the minus IO. Now remember, iometer on my volume is sitting at about 6,000 IOPS. So what I'm going to do here at first is I'm going to say, okay, I want to set a max to be, 9,000 IOPS. So at this point, it's under the max. So I'm setting up an IOPS limit. I could use the minus, and I'm not going to give it a minimum. I could give it a minimum. In fact, I'll go ahead and do that. I'll say, okay, I don't want it to fall below a floor of 1,000, but it can't go above 9,000. So you can give it a minimum max. But I'm below the max here. I'm going to use a priority of high. And then I can do a couple of other things, but then I say VVSet, colon, and give it the volume set name, which is QoS underscore PO underscore set. So I'm setting up a little rule here. So if I do show QoS, this will show me my current rules. This is the name of the volume set. It's high, priority high, IOPS min max. I didn't set bandwidth. I didn't set up a latency goal. All right. Now I'm going to do a command called statQoS. Oops, statQoS. This is one of those stat commands we talked about yesterday. And you can see I'm just going to stop the output, follow my cursor, volume set. This is the name of the set. This output here shows me IOs per second. The QT means basically my limit. Remember, I set a 9,000 IOPS limit, and it's currently sitting average max iometers running at about 6,000, 6,500. The current KBs are about 26,000, but remember, I didn't set a limit on bandwidth limit anyway. And then the current service time is about 0.2, which is right, because remember, we saw that in my report. Service time is about 0.2, 0.23. And so another command you might want to be familiar with is the srstatQoS command. There are a couple of options I can use. At time, I'm going to use my BT-sex. I'm going to say from an hour ago. Oops, 1H. SR stat QoS. That didn't work very well. Let me play with that. We're getting all zeros here. Well, the stat QoS work. Now what I'm going to do is I'm going to do recall that set QoS command. And what I'm going to do is you can use set QoS to change a rule. So now I'm going to do set QoS, a minimum of 10,000 IOPS, but I don't want it to go over 4,000 IOPS. Because remember, iometer is running at about 6,000 IOPS. I'll say priority high. Okay. And VB set colon. And remember my volume set is, what is it? Called QoS underscore PO underscore set. So now I'm essentially changing the rule and capping the IOPS to be 4,000. So remember, iometer is running at 6,000. So now, let me go back here. Watch, look at what's happening in my report. As soon as remember it was sitting at about 5,000, 6,000 all along here. As soon as I implemented the rule, the total IOPS dropped. And my service time went up from about 0.2 to let me set this in here. No, I shouldn't have done that. Well, it went up to about 0.4. It almost doubled. You can see up at the top, the IOPS here is about, now it's, sitting around 4,000, and the service time doubled as well, which is what we'd expect. And also, just to show you this from the command line, I'm going to do my stat QoS command again to show you how the stat QoS looks. And you can see in this column, the IOs per second. This is my limit. I said 4,000. It's currently sitting about 4,000. And the service time current bump went from about 0.2 to 0.4. Give me some averages, the wait time. And we're also getting things queued up. And the other thing too, if I go back here to iometer, if you can see in this, follow my cursor, the results since the last update. Start of test, we were sitting at about 6,000. If I click on the last update here, watch what I'm going to do. The last update, the host started throttling the workload to about 4,000. Okay. All right. So let's do this. We've got a couple more things to talk about in terms of PO and QoS. Well, let's do a bit of a break, and then we come back. We'll pick up where we left off. See you in 10 minutes. Okay, everybody, this is John, and I am back. Go ahead and put your hands up out there in the classroom if you're there and back. All right, so let's continue on. We don't have too much to talk about here with PO and QoS. So I showed you how to do this, create the, put a volumes in a volume set, enable it, talk a little bit about, the all others rule. Again, from the command line, you can use the command set QoS, set QoS to set. Here you can do set QoS minus IO for IOPS. Here you do a minimum and a maximum. Now you don't have to do a maximum. You don't have to do a minimum. But if you do a minimum, you do have to do a maximum. So if you want to set that minimum, you have to do minimum dash and a max. Same with bandwidth. A couple ways you can set the bandwidth. Here they're doing it in meg, but minus BW, priority high. The latency goal here, they set a latency goal of 12 milliseconds. And then you use the volume set, and then you can enable and disable them with the set QoS on and off, and clear means basically delete it. And a couple of things in terms of just some general considerations. Priority optimization doesn't pick particular volumes or hosts to delay that queue full message. Anything above an upper limit for the max will be properly delayed or rejected. The priority optimization determines whether a new request, like it's an IO, comes in, should be delayed based on the maximum delay of the existing queues in the existing requests in the queue. So it's actually looking at what's called the delay time. And if the maximum delay of what's in the queue is already greater than the allowed latency, PO will reject the request. This bullet item here I mentioned, the cache isn't impacted because the rules are checked pre-cache. We only queue up the descriptions or descriptors, not data. And so the impact of the rules are negligible on cache, CPU, and so on. Now, one of the things I mentioned when you create a rule is you can set what's called priority levels, high, normal, or low, okay? And in terms of that, you'll hear the term service level agreement or SLA tiers and the system busy level. All right. Now, one of the things, give me just a second here. One of the things that the system is keeping track of. And when I say the system, I'm talking about the array and what's called the quality of service algorithm. Is it keeps track of what it refers to as the system busy level. And generically speaking, it's the system busy level. I'm sorry, give me just one second here. And what happens with the system, it keeps track of what's called the system busy level. And the array calculates from the current measured latencies and what's called the latency values of the rules you have currently set up. You don't set what's called the system busy level, all right? But the system keeps track of there's a calculation called the system busy level, keeps track of to basically see how busy the array is. Now, what could happen? You can set priorities for your QoS rules. You can set a priority of low, normal, which is the default, or high. All right. Now, down here at the bottom, I want to look at this chart. At the bottom of this axis, they're kind of showing you what's called the system busy level. It uses latencies and current latencies of all, particularly the all others rule, and quality of service and a couple of other things to determine what's called the system busy level. And if the system busy is down or nothing's going on, the system busy level is said to be 0%. But as the system busy goes up, 10, 25, 30, 50, X% busy, busy, all right, what could happen is the array might start throttling certain workloads, all right? And let's say up here at the top, they talk about the bronze tier, the silver tier, and the gold tier. Your higher priority rules, and this is why oftentimes with the all others rule, you set those up, anything else that doesn't have an explicit rule with what's called a high priority. So if you have the all others rule set up with a high priority, and any other implicit rule set up with what's called a high priority, okay? What'll happen, let's kind of look at, this is what we call the gold service level agreement, the gold tier. So as the IOPS go up, we'll allow up to 10,000 IOPS, and we'll try to meet the 10 millisecond circuits left by throwing bronze and service workloads first. So what could happen is the system gets busy. Look it down here. As the system gets busier, the algorithm is going to attempt to start throttling certain workloads. Now, what they're saying here is any high priority rules will only be starting, it'll be, they'll be allowed to go up to 10,000. First of all, we may not have to throttle. If the system is busy, 10, 5, 0, 10, X% busy, it may not start throttling any workloads. But your higher priority workloads will only be throttled if the system gets 50% busier. It's a candidate be throttled down. Your bronze or your lower priority apps, if throttling has to take place, they'll be delayed first, the lower priority. We're not going to let, once the system gets 10% busy, all right, they could be throttled down, and the goal is and won't be rejected or delayed until we drop below 1,000 IOPS. This is where if you want to set a minimum for even your lows, you don't want it to go this is the goal without a minimum set. You set a minimum of 2,000 IOPS for a particular quality of service rule. So it won't, so what happens at 10% busy, you're fine. But once 10% busy, the lower priority apps, if they need to be throttled down, are throttled down first, and then the silver, what we call the normal, will only be throttled down if the array gets 25% busy and won't delay or reject below 20,000 IOPS. And the gold, 50%, the higher priority rules. And so the latency goal is the service, remember, if you can set a latency goal within your rules, it's the service time target the array will attempt to achieve for that rule. This is the key for adjusting the service levels, the SLAs. QoS will try to meet latency goals, but it can't be guaranteed. If the latency goal is too low, the system busy level goes up and all the volumes are possibly unnecessarily throttled, even when the load is light. But if it's too high, the system busy doesn't go up and no volumes are throttled. Here they're giving you some guidelines for setting latency goals. For your volumes and SSDs, around a millisecond is what's to be expected. This is a little bit about the lowest cap. Here's a little example now. This is again a kind of another report off here to the right. This report though, just to kind of let you know, is assuming you're using what's called external system reporter. This is not a report using SSMC, using the on-node database. This is fine. It's still, even though you don't have external system reporter, Bank of America, this is essentially kind of the equivalent of the report I was showing you, a report showing me IOPS and essentially service time down here. So they had the red application, the green application, the blue application. All right. Now red was the critical application. Blue and green are lower priority apps. So what they're saying here, if you look up here at the top, the red application was sitting at about 7,000 IOPS, blue and green. So what they wound up doing here is they put red, actually, let's start here. Around this time, they set up rules. And they put blue and green, blue and green in a volume set and set up a rule. And they said blue and green, put them in a volume set and set the cap to be 6,500. So around this time, green was sitting at about 6,500 IOPS and blue around 3,000. So they put blue and green in a volume set, and you can, at capping them off at 6,500, and you can see immediately blue and green's IOPS went down to cumulatively between the two 6,500, and that caused reds to spike. They also put red in a volume set as well. We wanted to cap off green and blue to help the reds performance here, which you see reds performance goes up here. But we didn't want reds to go as high as it wanted. I mean, we wanted reds to performance to go up, but we wanted to cap it off at 10,000. You can see red service time initially before the rule was implemented was sitting at about 8 milliseconds. As soon as the rule was implemented, dropped below 6 milliseconds. So it saw its service times increase. And of course, we don't want to see high service times. Green service time actually goes up. So now this I just kind of showed you from the command line. You can do show QoS, see your volume sets, whether rules enabled, your IOPS mins max, your bandwidth mins and max latency goals, your priorities. This is from the command line. And this is one of the commands I showed you. I essentially showed stat QoS. I kind of showed you this in my little demo. You can use SR stat QoS. I screwed up the syntax, so I won't really do it again, but you can use stat QoS, SR stat QoS to look at your volume sets, the IOPS, mins and maxes, service times, latency goals, and so on. And there is a nice SSMC report you can run called the priority optimization. This is the template, the priority optimization performance statistics template you can use to see the results of priority optimization. In fact, this is an example of this report in SSMC showing IOPS. You can see here they have the all others and rule and plus the volume set. You're seeing the IOPS over time and the service time here. We don't distinguish between reads and writes. We use an exponential average to throttle. You can use the set QoS commands and the create schedule command to schedule. So let's say you want to schedule a rule to turn on and off at certain times. You can use the create schedule command and the set QoS. You can't schedule enabling and disabling the rules from SSMC. We use volume sets as objects. The volumes don't have to be exported, or the volume sets don't have to be exported. I mean, if you think about it, if they're not exported, we're not getting any IOPS, so it would kind of defeat the purpose. But what they're really saying here is if you unexport a volume set from a host, you're not kind of getting rid of the rule. You could unexport it and re-export it, and then rules would be enabled. The key challenge is making sure you set the things properly. Latency goals, minimums, maximums. You don't want to set the minimums too high or too low. Same thing with the max, but this is kind of a, as you could see, I hope you can see as I talked about that, pretty easy to set up rules, pull up some reports, enable and disable them from the command line SSMC. But the key challenge really is, what is a proper IOPS maximum? What is an effective or a realistic latency goal? Setting them properly. You don't want to set maximums too high because if you set them too high, it somewhat defeats the purpose. Same with the minimums, latency goals, priorities. So So how many of you think you'll find a use for priority optimization? I know there was talk of you guys using it. Can any of you see a use case, if you will, for priority optimization in your environment? Yeah. Okay.
John, this is Manoj. Not really, because currently the 3PAR is being used as a block storage backend to our AHS environment. Priority optimization we would not be able to do on data stores, right? And this is a typical host deployment. I'm not sure, when in the roadmap, we will move to a HP array as an enterprise array to support individual hosts. So uh, that's the far and close of it. It's a good feature. Thank you for
Yeah,
showing us that.
it's good to know about. It is good to know about.
Absolutely.
At the end of the day, when I'm using the term host, like you on the second day, everybody added host, right? And what you wind up doing, adding a host, is adding worldwide names, right? So what we consider hosts are some worldwide names. And when, say, you export a volume to what we consider a host, we're actually granting access to the data on those volumes via the worldwide names, right? You got a host with a couple worldwide names. Those worldwide names can get at that volume or those volumes. And the other hosts that have different worldwide names can't get at the volumes. That's how we essentially implement LUN security. What can get at what volume, right? At the worldwide name level, what we consider a host. So when I'm using the term host, and of course they have operating systems and have support operating, at kind of the permission level, if you think of it that way, we're essentially granting access to the data on a volume via the worldwide names. When you add a host, like say an SSMC. So, but it's a nice feature, and I know you do have the license for it, and they wanted me to at least discuss it. So, do you know how it works and what it's all about? All right. So, let me pull up the slide I'm going to need for the last topic we're going to talk about. Now, one thing I want to, before I even get into this, I want to let you know that admittedly, I'm going to kind of get into things here at a high level. But before you wrap up here today, remember, you want to go out to that folder docs for B of A and save anything I have out there. But this morning, I added a zip file out there called EMCPM B of A, because we're going to talk about next what's called data migration, to migrate from to a 3-PAR array. But I know that you have an EMC array, and I believe that the majority of your data from the EMC array has been migrated or will be migrated to your 3-PAR array if it hasn't already. And I put 3 documents in this zip file out here on specifics on EMC to 3-PAR migration. Now, because admittedly here, what I'm going to go over is some kind of very high level things. All right. So we're going to talk about migrating data to a 3-PAR array and what's called storage federation. And you can hear me use the term peer motion, the benefits of PM, the concept of federation, and to use what's called the online import migration feature from non-HP 3-PAR arrays. All right. Now, let's say here in the middle is a 3-PAR array, like your 7440 or any 3-PAR array model. And if we talk about the term migration, you want to migrate data to a 3-PAR array. All right. We have a product, which is a licensed product called PeerMotion. And PeerMotion, or PM for short, allows customers to migrate from one 3-par to another, from an F7008 to a new array. That's called PeerMotion. So PeerMotion is solely a 3-par to 3-par migration tool. About 4 or 5 years ago, we introduced the feature called PeerMotion, and we did it at the time because we came out with a new model, and we wanted to say, hey, you know, we have this new feature that allows you to migrate from an F series to a V series. And the whole goal of PeerMotion is you can do what's called an online migration in most cases. So let's say you have a 3-par array, volumes exported to host, and you want to migrate. The volumes can be migrated real time, no downtime. The volumes remain exported to the host. Now, it's similar in concept to vMotion. You know, vMotion essentially allows you to migrate, no downtime. And our feature is called PeerMotion. Now, essentially then what we did at some point about a couple years later is we tried to break into the EMC market, trying to get people to come off EFC. And to do that, we said, oh, we got a new feature called, it's similar to the concept as PeerMotion, but we call it online import. Allows you to migrate from an EMC disk array to a 3-par array. Now you can migrate from an HDS or an XP array to a 3-par array using what we call our online import feature. And you can use online import from these are HP arrays, the HP EVA. So all of these are migration tools to allow you to migrate from non-3-par arrays, what we call online import. And then the PeerMotion allows you to migrate from one 3-par to another. Okay. And in most cases, you know, this can be done online. In other words, let's say you have a host and a volume is exported from, this is the purple volume, this volume is presented from an EMC disk array. You want to migrate this to a 3-par array, no downtime. Similar in concept to vMotion. Now, so let's say, since you're predominantly a VMware shop anyway, right? Let's say you wanted to migrate data from your EMC to a 3-par array. You can use vMotion to do that. But remember, vMotion is essentially VMware, right? What if I have a customer that you have a Windows host or a Linux host, you know, has some data exported or presented from an EMC to a Linux host, and you wanted to migrate to a 3-par? You couldn't use vMotion to do it. You could use online import. So a lot of my customers who are solely VMware shops, it's essentially a choice. There are pros and cons to both, but if you want to do some migration and you're 100% a VMware shop, you could use vMotion to essentially achieve the same thing, you know, migrating, no downtime. But for non-VMware, you could use this, and it's essentially the same concept. Now, what happened with the release 3-par OS 3.2.3, this year, you know, we've always had the product PeerMotion. But what we now, you'll hear the term PeerMotion and Storage Federation. You'll hear the term federation in conjunction with 3-par OS 3.2.3. Traditionally, with our traditional PeerMotion and the online import, PeerMotion was basically what we call unidirectional and usually used by our customers who buy a new array. So let's say this is one of my I have a customer that has a 7,000 series and they buy a new 20,000. They want to migrate all their data off their 7,000 to a 20,000. You can use PeerMotion to do that. But historically, it's been unidirectional. One way I can migrate data from here to here. But what we've had a big push from some of our customers who want to do kind of migration and balancing across your data center. Let's say your data center has 4 arrays in it. Just kind of go with me. You have 4 arrays, which I know you don't, but let's say I have a customer that has 4 arrays. And kind of not real time, but they want to push some data around from this array to this array, and they want to, kind of balance. This is what's called a federation. It's essentially bidirectional replication between up to 4 3-par arrays. So it's kind of a beefed up PeerMotion, bidirectional. That's what federation is. So, and I'll show you kind of how this works here. Ron, question?
Sorry, I unfortunately, yes, I've been multitasking, so I might have missed this, but I think that this is pretty important to me. And I apologize for not listening earlier in this section. Is all of this completely a non-disruptive move from the server's perspective?
Well, when you do, now it depends. First of all, with PeerMotion, which is the 3-par migration tool, you can do what's called online. It's non-disruptive. From EMC, if you're doing what's called the EMC online import, this usually you can do what's called an online migration, but it usually involves a reboot of the host afterward.
Okay, so you're going to change worldwide names, you're going to change, and ultimately going to have all those other port changes and that, so you don't you don't do the same game you're going to do for your PeerMotion, which you're going to fake out the worldwide names, where you can't do that with the VMAX or external company arrays.
Right.
Okay.
Right. And by the way, we just started here, but maybe you were away. One of the things I just and let me kind of pull back here for your sake. Admittedly, here in this chapter, maybe you didn't hear this, maybe you did, but let me go to Ron, for you, Ron. In this chapter, what I'm going to go over is some very high level stuff. I don't have a lot on the EMC to 3-par migration, but in that handouts folder, I zipped up a file that has 3 documents and goes into a lot of detail, particularly on the EMC to 3-par online import. So, my slide deck here is kind of very generic, to be upfront. I mean, if I had a topic here talking about PeerMotion, federations, migrating from an EMC or an EVA or an HDS or an XP, we could be here all week. So I have some high level stuff here in terms of some of the concepts.
Right.
But
well, I'm just not even focused on EMC, right? I'm looking at this even from a generic perspective. Mm-hmm. Yeah, of course, we have a lot of EMC product. But if I was able to, let's say, choose HP 3-par today and get to it non-disruptively, and then tomorrow, because I've used HP 3-par, and for some odd reason I don't want to use HP 3-par, or I have some other special requirement to move off of it, if I can go into and out of HP 3-par non-disruptively, that's an important thing for me to know.
Well, you're going to be able to do non-disruptively to and from HP 3-par, but you're not looking at, like, if you want to push data from an EMC to a 3-par and then back, that's not going to be non-disruptive.
Okay.
I mean, our online import is really for importing. Think about our business goal. We wanted to break in the EMC market. We want you to be able to pull your data off your EMC into our 3-par, not the other way around. So the 3-par to 3-par with particularly federations can be bidirectional. All right. So that's what we're getting ready to kind of get into here. This is only the 3rd slide, so you really didn't miss anything.
Okay, thank you. I apologize. I unfortunately still have,
Don't apologize.
Focus on training.
So PeerMotion, like I was saying here, historically with our initial product that came out, about 4 or 5 years ago, PeerMotion could have a volume exported to this 3-par host from this 3-par and migrate it. But, usually even with PeerMotion, historically it was just kind of, get your data off your old array to your new array. It's usually it was unidirectional. So you could migrate data from this array to this array, but then if you wanted to migrate data from, you go in this direction, but if you can only create a relationship between 2 arrays and go in one direction. So if you want to migrate some data from here to here, you could do it. Then you have to tear down the configuration and create a new configuration if you wanted to, replicate from here to here. And, it wasn't kind of real time, but that's a segue to the federation concept. The federation concept, which is coming out with 3PARS 323, allows 4 3PARS in essentially a bidirectional sort of replication solution. That's what we call now federations. So it's essentially bidirectional migration between up to 4 3-par arrays. And that's kind of the new feature for data center balancing across up to 4 arrays. But there could actually be 8 arrays involved, but hold that thought. So when you hear term federation, essentially is bidirectional PeerMotion. But let's talk about PeerMotion in general, which is solely, when you hear that term, the license PeerMotion is 3-par to 3-par. So PeerMotion in general, here they kind of compare PeerMotion to traditional block migration. And we're not talking about vMotion, but let's say you didn't have things like vMotion or PeerMotion. Let's say a customer, has an old array, they buy a new array, they wanted to migrate some data. They're looking at, having appliances and downtime and cloning and rethinning and downtime, point-in-time point-in-time migration. So with PeerMotion, just in general, let's say this volume, this is PeerMotion, not online import from EMC or any of that. Let's say this volume is exported to this host from a 7440. This is one of the volumes exported to one of your hosts. And let's say down the line, you do purchase, say, a new 8450, so one of the other new arrays. With PeerMotion, when you can do what's called online migrations, which basically means this volume can remain exported to this host, and this host is taking reads and writes. Well, I got to give you some details, but basically they're not looking at downtime. This volume is exported, or volumes are exported to this host. You're going to kick off the migration. No downtime. That's online. With PeerMotion, pretty much everything can be done online, PeerMotion. And I'll give you some specifics, but once the migration is complete, the volume is just going to be rerouted, IO rerouted to the new array. This volume will essentially have the same worldwide name. So bottom line here, you can do online migrations. All right. Now, see, the thing with PeerMotion, we've had a number of iterations of it, since 2011. 2011, there were some operating systems, like, believe it or not, when this feature came out, PeerMotion, back in 2011, you could not do online migrations for HPUX hosts, which is kind of not a good thing for us because we're HP, right? Soon to be HPE next week, but in any event, you couldn't do an online migration. Eventually, over the years, HPUX was supported. There were a couple of other operating systems up front that you couldn't do online migrations. But by now, pretty much with PureMotion, everything can be done online. Now you can always, and you can still do what's called an offline migration. Now offline migration means essentially this volume is unexported, migrate it, and then you re-export it post-migration. All right. So the main selling point of PureMotion in general is, the fact that you can do online migrations to migrate from one 3-part to another, no downtime. All right. And, one of the nice things as well, it's online particularly is non-disruptive from any 3-part to any 3-part, and it's then built in. And that this is actually nice as well, because let's say I have a customer here that has like on their what we call the source array, a fully provisioned volume. When you can migrate it, you can make it thin. Or let's say I have a customer here that this volume on the source array is thin, and now because they don't have SSD capacity, their new array has SSD capacity, and when they migrate, they want to make it thin deduped, so it's thin built in. And even though we all have said, you could use PureMotion for load balancing at will and do tech refreshes and so on, the original PureMotion was one directional. In other words, you could migrate from from this array to this array. You built what's called a PureMotion config, kind of like with remote copy. Yes, they create a remote copy config between 2 arrays, but it was one directional. So if you wanted to migrate some data from here to here, you could create a config in this direction. If you want to go in the other direction, it should break down the config and go in the other direction. So even though we said it was load balance, could use for load balancing and so on, wasn't as robust. It was normally used by our customers. It still is for customers who want to migrate from one 3-part to another. So a little bit of just some general introduction. It is with the online, a non-disruptive migration data from one 3-part to another for PureMotion. And so no loss of access during the migration for supporting operating systems. Well, by now for PureMotion, every supported 3-part, we support operating systems supported 3-part in general is supported now. Now, during the migration phase, it's possible that you could see a slight performance impact, because just like I've mentioned a few times this week, anytime you're pulling data off the disks, move them to another disk, in this case it's a disk in another array, you're causing additional work on the array. So now you don't need to no modifications are really required on the array you're migrating from, the 3-part array, because there are some things you're going to have to do, like they tell you you're going to have to configure what we call peer port for migration. But what they're saying here is, like, let's say for example, down the line you do purchase a new 20,000 array, and by that time we've come out with 3-part OS 324. So if your old array, let's say your 7440 is running 3-part 322, your new array is running 324, that's fine. You're not looking at having to upgrade the versions of the 3-part OS and so on. As I mentioned already, to migrate, you can do thin to thin dedupe migrations. You do need a license. So the EMC migration, you don't need a license. Essentially, it's free. But for PureMotion and PureMotion federations, you're going to need a license. Now, we now have, if you're running SSMC 2.3, in the mega menu, there is now an area called federations, where you can go in and set up what's called your pure motion configuration, or your federations configuration relationship between two arrays. I'll show you that in a few minutes. But once you set up what's called the relationships between the arrays or arrays you want to migrate from, and some of you might have noticed this in some of the screen scrapes I showed you along the way this week, but from there, like here, let's just look at this example down here in SSMC. They're in the hosts area. They've highlighted a host. This is the name of the host. Let's assume this host has some volumes exported to it. Under actions, you can then start doing the pure motion migration. So you can essentially migrate from one array to another once you create what's called your configuration at the host level or the host set level. You got 10 hosts in a host set and all those volumes exported to the host set, so you can start pure motion. You can even do it at the volume level, even choosing multiple volumes, or even at the volume set level. Now you can do pure motion migrations, although now kind of it's a play on words. We now call it federation pure motion. You can also work with it from the command line, but it's much easier to do it in the GUI SSMC. They're just telling you here there's integration now with SSMC and Management Console. It's pretty easy, straightforward. And this is just kind of a screenshot. I'll show you some details here as we move forward. Now, I've got some high level, if you will, I guess slides here on concepts. Let's say this is a host up here, a couple of switches here. And let's say this is what they refer to as the source array, right? Let's say this is the destination array where you're going to migrate some data, maybe all of it or part, back and forth. But you've got some data here you want to migrate. Let's say this host here up at the top, the source array, has 2 volumes export to it, to this host. So what they're showing you here is kind of before and after. So they haven't gotten this new array yet or configured it, but they're actually showing you the fiber channel host link. So this host is essentially reading and writing to the volumes down 2 paths to 2 controllers. In this example, of course, you have 4 controllers, 74. So all they're saying here is they're showing you the paths here, from the host, what's called the fiber channel, that they're reading and writing to these volumes. All right. Then they buy a new array. So when they buy a new array here, just kind of go with me. Here's their source array, and the source is off to the left. This is the destination array off to the. They're going to migrate. So again, we assume that the 2 volumes are still exported to this host. This host is still reading and writing to the volumes. Now, so the red line here is representative of the front end host interfacing ports. We're doing an online migration here. This red here are the front end host interfacing ports that the host is reading, writing to the volume. Now, so let's say we want to migrate some data, have a brand new array here. Now, I'm going to jump around here a little bit. On the destination array, on 2 different controllers, only 2. I know you have 4. On 2 only 2. You have to have a couple of ports set up for peer port, what are called peer ports. This is essentially how we're going to migrate the data, the peer port. These have to be dedicated ports, and these have to be fiber channel ports. You have to be dedicated up front, at least initially. All right, these are peer port. Now, on the destination array. On the source array, the array you're migrating from, you have to have a couple of ports set up as host ports. Now, see in the picture here, they're saying here these blue ports here are host ports. So to migrate on the source array, you need 2 ports, no more. You can't do less or even more than 2 ports on 2 different controllers. set up as host port to migrate the data via the blue links. These are what we call the peer links or the migration links, the blue line. It's basically a couple of host to a couple of peer. All right. Now, on the source array, these host ports don't have to be dedicated. In other words, remember, these red ports here are host ports. These are how the host are reading and writing to the volume on the source array. These don't have to be dedicated. You could actually use, I mean, these, you don't have to have dedicated host ports. Because really what happens is this array sees this array like a host, and it really kind of does something like an export. So you could actually use these ports, okay, for migration, or have dedicated host ports. But you definitely need a couple of ports on the destination array as peer port set up to migrate to an array. Now, let me kind of bring something else in the conversation. This is kind of traditional peer motion. Let's say you want to do federation, basically migrate from this array to this array, and then some data from this array to this array, kind of full time, if you will. You are going to need a couple, if you want to kind of keep migrating back and forth between this array to this array and this array to this array, you don't want to go and keep flipping these ports around. So what you are going to have, I know this, you're going to have on your source array, you're going to be using a couple of your, on two of your controllers on your 7440, you're going to be using the 8 gig fiber channel port, the onboards, okay, essentially, which will be set up as host port. All right. I'm sorry. These are going to be, well, you're going to be using these as, okay, let me explain myself here. You're going to be migrating, well, right now, or at least initially, you had an EMC array. And you're going to be migrating to a 3-par, your 7440. So on your 7440, you're going to have a couple of ports, fiber channel ports set up as peer ports, and you're going to migrate from the EMC to the 3-par array, or you did. And you used a couple of the onboard fiber channel ports. So in fact, let me use this. Your destination array is a 3-par. So you're going to migrate, your 2 peer ports will be your 2 onboard 8 gig fiber channel ports on your 7440. Now, later on down the line, like Ron, you were essentially asking, you know, maybe you get another array in the future, you might want to use peer motion to migrate from one 3-par to another. If you want to kind of do real-time migration, you're looking at having a couple of peer ports on both arrays to maybe to migrate to and from in a federated sort of environment. But let's say, let's keep this simple for now. Let's say I have a customer, you down the line buy a new array, you want to migrate all the data off one or another array. You need a couple of host ports on the source array that might be dedicated or not, a couple of peer ports to migrate to. The blue here represents the peer links or the migration links. And essentially what happens during the migration phase, your host, now remember also what's in the picture here, your host during the migration phase will see, in this example, 4 paths to the disk. The one thing that was actually left out on this slide, what they're really kind of showing you here, is to set up the peer links to migrate. But remember, eventually if I want this host to migrate, I'm sorry, read and write to the volume on the destination array, you're going to want to have a couple of links, host links here, right? To read and write down here. So during the migration phase, it'll see all the links, all 4 paths during the migration phase. Ron, question?
Yeah, so you're accomplishing this. So ultimately, the non-disruptive part of it comes from that. Okay, great, you're moving it over, and you're going to auto mask the ports and the new LUNs over to the server.
Right.
Server is going to also require recognizing a net new set of worldwide names. So I thought initially maybe you guys are going to do some WWN spoofing or something like that.
No.
Migration completed.
Well, it really, what winds up happening is the volumes, actually the volumes will maintain their worldwide names. The volumes will
Right.
maintain the same LUN numbers, the volume names, the worldwide names, and so on. What will happen during the migration, I don't know if I would call them spoofing, but what actually happens, like remember here, the host was initially seeing 2 paths, right? And during the migration phase, it'll just actually see all the paths to both arrays. It just sees the number of paths. It still looks like it'll still have the same LUN number, the same worldwide name. But what actually happens is during the migration phase, we do a couple of snapshots off of the primary, off the volumes on the primary. But actually what'll happen is writes during the migration phase will go to both places.
All right.
All right.
Is there any
For EMC though, if migration from your EMC, there might be some things you might have to do with power path.
right? In some cases, we're using the OS native.
Right. For
tab,
native,
but,
don't worry.
yeah.
You don't have to worry.
All right. And the reason I'm asking this, right, is I'm trying to understand if, let's say we were in a purest HP 3-par world, what are the things that the server would recognize during this transition process, and how much interaction would we need from the, SAs and other folks?
Yeah. Actually, not much. You set up these ports.
Right. There's events, right? It's rezone.
Yeah.
Right, which we have a policy on when that can occur.
Okay.
There's then there's still going to be a state change notification that's going to go out. There's going to be a recognition of new LUNs at the array.
I see.
I mean, at the server side. So
Yeah.
I'm just looking. I'm trying to understand the impact and what kind of pushback we'd get from our CTOs.
Yeah. Well, there are some things, like you said, events that have to take place, and in terms of how that's going to work with how you have to alert certain OS admins or people at the switch,
right,
who work with the switch, and your
but
powers
the key
that
is they would not. The key is they wouldn't be mounting to they wouldn't have to actually take action on the operating side to remount to the new LUN because of all that sameness in the worldwide name and everything at the LUN level.
No, nothing like that. It's actually pretty transparent. And one thing, he's probably not gonna, one of the things I'll write out here in the chat is the name of our HP rep. And I don't know where he's at, what site he's in. I think he's in the New York area, or New Jersey. His name, and I mentioned it earlier, Tibor Tarek is his last name. That's his email. You bring up a good question, or bring up a good point, Ron. When I was teaching the classes like face-to-face in Charlotte and New York, he was there, and there were a lot of questions on things like that were kind of out of my scope, because he's on site and he knows your, essentially your applications and your business and so on. So there was a lot of kind of play in the face-to-face classes, and people were asking kind of the same things, but what were we doing, and so on. Since we're doing this class online and I don't really have the background in terms of your environment, that's a good question to ask him. If you have any questions, you might want to keep his email out there. How many of you have met Tibor? I didn't really meet him until, I went to one of the classes. Have any of you met him at all or had any interaction with him? that's a good email to keep for kind of specifics. Because he's been on site, or he's been working with our salespeople, and he's been on, I can't remember which site. I think he travels around to some of the sites, a number of the sites for Bank of America doing things. And he's really good in terms of applying it to your environment and your applications. And that's probably a good source for you to ask kind of questions in terms of that. So might want to keep that email. So during the migration phase, I don't know if I would call it a spoof, but it is pretty seamless once you set up the ports. And the zoning, you know.
So it sounds like, technically speaking, it's not a major event for, let's say, the operating system side, other than seeing that things go smoothly. There's no real action for them to take, just monitor.
Right. So, and how I took your question is things that are happening, like here, this host, you know, whoever this admin is going to maybe see more paths to the disk and get, you know, not so much confused, but what's going on. Think administratively or procedurally, the steps you need to go through for these things that might happen. Like here, this host might see go from 2 paths to 4 paths, and, you know, events being happening, and what you need to do kind of at the switch level and so on to set up these peer ports and zoning and so on. And eventually, if you have to flip these back administratively or procedurally, if you will, within your organization, you know, who you have to work with, notify, let them know, you know, what's going to happen. That honestly is a better question to ask him. But in terms of the actual process or the feature, if you will, it's pretty seamless. And I do have, like you brought up, the multipathing, particularly from, not so much with PureMotion, you just take, you know, all native, but, you know, if you're using things like PowerPath, SecurePath, which I have had some customers, but from an EMC, and even actually from a PureMotion point of view, but particularly for EMC, there are some considerations. But overall, you know, you don't have to work with your load balancing policies. Why HP, particularly for the arrays, is moving forward with native. We used to be in what's called the secure path business. We're out of the business now, and wanting for all of our arrays really you to move forward with the native load, whatever the solution is for the operating system. And what really happens, I know this is kind of simple stuff, but what happens, even if you're doing things from the command line, you actually wind up here doing what's called an admit VV to admit it to the array. But in the GUIs, once you set up the relationships, you set up the peer ports, you know, then from there you just go in and migrate things at the volume set level or the host set level, or the host or host set level, volume set level. And yeah, the hosts might see multiple additional paths. Writes go both places. Reads will come from the old array unless it's a new write. Writes will go to both arrays. A read will always come from the source array. And then essentially they're showing you kind of, if you were post migration, if you will, like let's say you wanted a one-way migration. You know, what they're saying here, let's say you get all the data off of this array, you know, in this example, then you want to unzone this host from this array. The red represents the new paths to the new array, seeing the 2 paths. And then if you're, you know, if it's a one-way sort of thing, then remember these are peer ports on the destination array, then you can flip these back to use something else. But if you're planning on doing, you know, real-time bidirectional replication between these 2 3-par arrays, you might keep these peer ports here in blue. Or not, or flip them back to use something else, RCFC or host. And voila, post migration. Now in this example, they're assuming here it's a one-way. You're getting all the data off this array and decommissioning possibly, right? And you can migrate, as I mentioned, in SSMC. Some of the slides here are a little blurry here, but they're showing you here, they're in the volume set. Yeah, this is a virtual volume set. You're going to start a pure motion at the volume set level. When you do pure motion at the volume set level, here's the I'm sorry, let me go back here. This is at the virtual volume level, not the volume set level. They want to migrate one virtual volume. So here, this is the virtual volume. This is the host. This is the operating system of the host. It's Windows. This is a source array. And it's possible, like in a federated system, you might have three other 3PARs you could migrate to. You choose the destination. Then you choose the destination array, user CPG. Okay, so you have to choose the destination array. And by the way, if you have snapshots, first of all, you have snapshots off of this volume, they won't follow. All right. And remember, although since you're an all SSD shop, at least at this point, when you migrate, you choose a destination array and a destination user CPG. This copy space CPG on the destination will be the same as the user CPG. And then it asks you, do you want to keep the source volume post-migration? You want to keep the source volume on the source array or delete it? The default is delete it. After you're done, do you want to create a snapshot on the back end? And you can do an online. Now, online basically means this volume is exported. Offline would mean you choose a volume that's unexported. And then you could choose multiple volumes here and you start. It's pretty easy GUI-wise. You cannot migrate a snapshot. Although in a way I lie. You technically can migrate a snapshot. But what happens when you migrate a snapshot, it winds up to be a base volume. It's not a snapshot. So you can take a snap off of a volume at your source array and migrate it, but it becomes a base volume. It doesn't wind up to be a snapshot. And this is kind of the same thing, but similar screen, but you can migrate volume sets. They chose a volume set. It's kind of the same stuff. Destination array, snaps, online, offline. You can migrate at the host level. Here they chose a particular host, and they're going to migrate all the volumes exported to a particular host. Same kind of prompts. And we did, and one is missing here, host sets. You can do it at a host set level. We do support, one of the nice things with 3PAR 322 is, and I just want to kind of mention this briefly, and this won't really apply to you right now. And to do this, you have to do, this is kind of cumbersome, at least right now. We support this from the command line. When you were migrating using PureMotion in the past, you essentially had to recreate your remote copy group. If remote copy was, like if your source array, you were migrating from array A, you were replicating from array A to array B, and array A was at your local site, you wanted to migrate, you basically had to migrate and recreate all your RCs or look at some major downtime. But now we've supported a seamless restoration of your, because what essentially we do is we take some snapshots at the primary and target. Once you migrate, we compare the differences and catch the targets up. So it's kind of nice for our customers who have remote copy, and it works with synchronous and periodic asynchronous as a 3PAR 322, as well as the asynchronous streaming when that version comes out. Now, the storage federation concept, here's what's new with 3PAR OS 322. You're not using EVAs. We introduced a new, what we call PureMotion PMU utility, a separate command line for PureMotion. But the main feature with 322 is peer motion between up to 4 arrays. Like here, I'm sorry, let me box this up down here in red. Here are 4 3-par arrays running 322 using peer motion, what we call a federation, in a bidirectional solution. So this is what's basically new with peer motion with 322. A couple of things, the federation and the remote copy part of it. We now, of course, have the 16 gig fiber channel ports in the newer models. But this is what we call storage federations now. So historically but it uses basically peer motion and bidirectional replication solution. And one thing I do want to mention here is at the time this slide deck was developed, there wasn't a lot of technical detail on the federations, but it came out in the past couple of weeks. So I'll go over a few things with the federations. Federation basically means you can have up to 4 arrays replicating between each other in a bidirectional replication solution. But before I go into a little of that, let's take a quick break. Been at it for a little over an hour. Let's take a quick 10-minute break and we come back. We'll pick up and then we'll take it from there. See everybody in 10 minutes. Okay, everybody, this is John, and I am back. Go ahead and put your hands up out there in the virtual classroom if you're back there and alert. That's probably the last time you have to do this because we don't have much to talk about here. And then there's a short lab you can do, and I'll go over that. All right, so let me pull up the slides where I left off. Okay. I'm sorry, let me go back here. All right. So in terms of peer motion, even what's called federations, you can use SSMC to create what's called your peer motion configuration, or now called your federation, federated configuration between four 3-par arrays. Or you can use the standard command line, but we introduced what we call the PMCLI. You could use as well for migration. And it can be, it's good for, orchestration of scripting if you want to script or, kind of schedule peer motion. They talk a little about have to be installed a Windows host and some specifics on the processor, etc. And it supports all peer motion management console use cases, or even SSMC, essentially creating the configurations and kicking off the migrations. Here's a list of all of the PMCLI commands, and I have some examples. You add your source array, you add your destination array, you have to use create migration to create a migration job. You can start the migration and do show migration. So there's a series of PMCLIs. Now, what I think the one takeaway you need to take out of these 4 or 5 slides is if you are going to migrate from an EMC disk array, you have to use this PMCLI. All right. So I know I didn't go, this is a list of all the commands and so on. Now you can use the PMCLI for peer motion, but to migrate from an EMC, you have to use this PMCLI. All right, it's all command line. And let's talk a little bit more about storage federations, this is kind of an excerpt of the federations area in SSMC now. And what they're saying here is you could have up to 4 3-par arrays, up to 4, in a bidirectional migration, what we call a peer motion. Basically, a federation is a peer motion bidirectional migration between 4 3-par arrays. And this is good. You have to be, these have to be running 3-par 322 or higher, then do it yourself. And the whole concept of this, as I mentioned at the start of this conversation on this topic, was peer motion, which is pretty much solely 3-par to 3-par. Historically has been one directional. And the nice thing about this is you can, do work, basically data balancing in a 4x4 type of configuration for balancing data across your data center. For aging of data, maybe a customer here has one of the newer 20,000s. Let's say this is a 20,000, and they buy a kind of a lower end, if you will, 7,200, right? This 20,000, this is actually not a great example because that's not a 20,000, the picture isn't. But let's say I have 20,000 with SSDs, and they run certain applications on SSDs during peak periods like the holiday shopping season. Or let me give you an example of one of our customers who is going to be using the bidirectional federation is Disney. Disneyland, Disney. And one of the things, I was actually at Disney in Florida, not Disneyland, Disney World, but I was at the operational headquarters, and they were kind of one of our initial, they were doing a lot of testing for us with this bidirectional federation. And one of the things they were using it for is, and I didn't realize this, but I guess Disney owns ESPN. And one of the things they were doing is they house a fantasy football, what would you call it, a fantasy football, a league, but I mean, I guess you can go online and join their fantasy football league, and they basically have a 3-part array dedicated for their fantasy football business. And so what they're doing is they have their, it's a handful, it's a number of databases, but they have during the holiday, not the holiday, the football season, you know, from like August to January, February, I guess, once the Super Bowl, is they've got their databases that are housing these, you know, fantasy football database on a new 20,000, well, an all SSD array, because it has to be on the fastest media. Well, then they want to age it. People that have the fantasy football subscriptions, you know, after January, February, they can still log in and look at stats, but it's certainly not doing trades and so on during the season. So after the football season's over, they age it to a 7200, which only has, you know, I think 15K FC disks. So this is nice for aging if you just want to balance across. That's the whole concept. And you know, the whole goal is data mobility. This is kind of picture over here is 4 3-par arrays scaled out across federated systems, load balancing, pushing data around from array A to B, B to C, age of stale to lower cost, you know, arrays, if you will, or cheaper storage and asset management, optimization, persistent data protection. Seamless refresh, do minimal impact. Basically, the whole goal is an active data center. It's built in. You have a single plaintiff class, particularly with SSMC. You're not looking at having to buy, you know, appliances and again, you know, this is basically you can do things at the host volume set level. Now here's a use case kind of. I'm not going to, on the slides, and you can pull up the slide deck as well. I have in the zip file, they're kind of showing you here. They have 4 arrays in a bi-directional sort of replication. They have an all SSD, a high-end maybe V series, a V800, a couple of mid-range arrays. They maybe want to migrate some data from their old array to a new array, and then, you know, can add and remove members of what's called the federation. So if this is their old array, they want to migrate from data from here to here, just one directional, and then from there kind of push it around and take this array out. But the arrays have to be running through press 322. And let me kind of flip back here. They have to be running 322 to do bi-directional. And if these, let's just kind of, if I plan on migrating between these 4 arrays, you're always going to have 2 peer ports defined on all these arrays long term to migrate, and 2 hosts to migrate from, and 2 ports to migrate, 2 peer ports to be a target to be migrated to. Now, if these are my 4 federated 4 3-par arrays and a 4x4, see, the max you can have is 4. But if you read some of the documentation, they'll tell you you could have up to 8 arrays involved in or maybe even more, but in this picture they have 8 federated 8 arrays as part of an overall federated storage use case. And in other words, let's assume these 4 are 3-par arrays here, running 3-par as 322. But you could also have up to 4 arrays outside of the federation. Like this array is a 3-par array running 3-par OS, not 322. This one, this one, this one, and this one. So here we've got 4 3-par arrays that aren't running 3-par OS 322. So maybe they want to do a unidirectional migration from these 4 outside of the federation, and then federate bidirectionally between these 4. And these 4 arrays outside of the federation could be non-3-par arrays, including your EMC disk array. All right. But in terms of the EMC migration, let me just kind of mention this. You can migrate data from your EMC to, say, a 3-par array. But you can't use our feature, what's called online import, to migrate from a 3-par to an EMC. Everything is in, and then from 3-par to 3-par. If this is a federated array, you actually have 2 options, and this is actually kind of what I was mentioning here. On these 4 arrays, you see the blue circles here represent the peer ports. The green circles represent the host ports, and they're kind of, I know there's a lot going on here on this slide. There's talking a little about the strategies in terms of the zoning between the 4 federated arrays in a bidirectional replication relationship. You can do single initiate or single target, or you can do what we call the 2 all-in-one zones, which are the red. Here they're kind of showing you the red zones and the black zones. The black zones between the federation. So you have a couple of options in terms of the zoning between the up to 4 arrays. Now you don't have to have 4 arrays for bidirectional. You can do bidirectional between 2 or 3, but not more than 4. I have some examples here. Here's the federation, you know. Here's 4 and 1 outside. Non-3-par, maybe your EMC. Here's a 4x4. These are kind of redundant, you know, as I mentioned here, the 4 members of the federation. The maximum number is 8. And here's just another example. These 2 are, you know, the maximum number is always 8. In other words, like here, as part of a federation, they have 2 arrays, 3 pars going bidirectionally. And since there's only 2, not 4, they could have 6 outside arrays outside the federation. And what I've got here is a simple screenshot of an SSMC setting up your federations. But they've actually gone into the federation area. They actually have a federation set up with a couple of 3 pars bidirectional. This is the map view. So to create a federation, though, you have to go into federations and you have to build this relationship between the 2, 3, or 4 arrays. And this is kind of blurry, but you give your federation a name and you choose the arrays, ports, peer ports. You have to set up the bidirectional relationship between the 2, 4 arrays. And once you have it set up, here they're just kind of showing you some views in SSMC, the overview. You can actually monitor your peer motions and your ongoing migrations, or even your current, or we wind up with two federations here. One is in the process of migrating something here. An online import from 3-par is, now this I'm going to skip because this is the EVA. You don't have an EVA. And the EMC, I encourage you, oops. I'm missing a slide, but for the EMC, you're going to use the PMCLI. Here they're just saying, you know, use the look at the documentation. I dumped the documentation out there. They give you some steps here. These are the models, the EMC, the VNX, the VNX2, and the VMAX. we use a utility called online import. You're going to have to use the PM CLI. This is, again, if your source array is a EMC array, your destination is a 3-PAR, you still need a couple peer ports on the 3-PAR array and a couple of host ports on the EMC. They don't have to be dedicated. Here are the models and the destination 3-PARs. I admittedly here have some high-level stuff. Here they've installed the online, what we call the online import utility for EMC, which is essentially the same as what we're calling the PM CLI for peer motion. And you have to do things on the command line. So again, I know that I went through some of that pretty quickly at the end, but I did mention that you should pull those, for the EMC, pull those documents I mentioned a little bit earlier today. Now let me go over here, a couple of things here. Let me go over the lab or labs you can do. Give me just 1 second here. So let me pull in my lab sheet here. Okay. So this is the same thing you've been working with essentially all week. And let me go over the lab or labs if you choose to do the lab. There's one lab you probably want to do, which is similar to the PO QoS lab I did a little, or demo I did a little bit earlier. There's one for PO and QoS. It starts on page 93. Let me go over that lab here real quick. And on page 93, sorry, it's a little slow here. And on page 93, what they're going to tell you to do is, sorry, let me find it. They want you to essentially, and they'll tell you in your Windows host, you may have two. You know, yesterday you created some 10 gig volumes for remote copy, or maybe created some volumes for System Reporter yesterday, or any volumes you created this week. They want you to have volumes, or at least one volume exported to your host. And then they're going to they tell you to use Iometer to set up a workload. And remember, in the lab yesterday, I went over that. In fact, if you kind of walk through the lab up through here, they tell you to, you know, set up Iometer. They want you to generate a workload on a vault, you know, and then what they're going to have you do, set up Iometer. Then they're going to have you take the volume. Then you're going to skip to actually, one of the things I want to point out here, remember, we're not going to be able to do this using the GUI because you don't have the latest version of SSMC. So what I have you do is working with PO and QoS from the command line. So, you know, I have you basically creating a volume set, setting up Iometer on it, and then, you know, doing some things from the command line. All right. And so it's a simple lab using the CLI. Basically, it really kind of shows you the demo I did earlier today. The lab I have designed for you doesn't really have you go out and look at that report I showed. If you want to do that, you can then do that. There is a lab as well for peer motion. And let me kind of go over that. If you want to do the lab for pure motion, I don't have it listed here. I'll leave it as optional. What you wind up doing is using these arrays, like you'll have a volume exported to a host, then use the remote array you replicated to yesterday as your destination array, and you wind up migrating from one 3-par to another. But here's the thing. If you want to do this pure motion lab, again, you have to use the GUI management console. The version of SSMC we have out in your lab environment doesn't support working with pure motion using SSMC. So let me go over that lab if you choose to do it. But remember, if you choose to do the pure motion lab, you have to use the GUI management console. And but the lab actually starts on page 163. And then basically they'll have you do a few things. Make sure you have a volume exported to your host with some data out there. Make sure they'll walk you through using management console to make sure your peer ports are set up on your destination, and they will. Then you use management console to create what we call a PM config, and basically go through the motions of migrating a volume export to your host, doing an online migration. So if you want to do the lab on pure motion, you can do that, all right? It starts on page 163, but just note you would have to do it using management console. So I'll write that out there down here at the bottom. There's a PM lab using management console starting on page 163. And I'll leave this as optional. All right. But the new lab is a little lab on priority optimization and quality of service. If you do the pure motion, remember you're going to migrate from this array to the blue array, the one we used as your remote site array yesterday for remote copy. All right. Okay. Now, with that being said, that's going to be it in terms of new material. And the rest of the day is essentially lab time. Now, a couple of things as we wind down here. If you wouldn't mind, before you sign off today, doing a class evaluation, go out to that site. I just copied and pasted in the chat room. In fact, you can click on the blue link. When you do that, it'll ask you for a course code. The course code is HK906X-67862. In fact, I've written that out here in the classroom as well. You can get it from the chat room. If you wouldn't mind doing a class evaluation, we would really appreciate any comments you have, suggestions, the material, the book, the labs. We would really appreciate it, number one. So if you have to do it right now, but if you wouldn't mind doing it before you finish today, we would appreciate it. And expect a class certificate in the mail. I'm sorry, not in the mail, via email next week. I don't do it, but somebody else does it. You'll be getting something from our admin assistant. She sends out the class certificates via email. Expect that sometime next week. The rest of the day is lab time. And remember, your equipment is available for you tonight until 6 p.m. Pacific Standard Time. So it's really only close to 11 o'clock now, so the equipment's available for another 7 hours. Now, after 6 p.m., if you're on the equipment, they probably will boot you off because they start kicking off the installs for the next week's class. But the equipment's available for you for another 7 hours. So even if you may not want to do these, no, I'm sorry, you can't. I know every class that I've done for well, I get that in a lot of my classes. They really kind of we really can't. It's not kind of up to me anyway, and they don't allow us to do that. So it's really available until the end of the class time, 6 o'clock tonight. So there are a couple of new labs, but if you want to do those, but take advantage. If you don't want to do these labs, or feel free to use the equipment to do other things all week, do some snapshots, remote copy, reports, CPGs, hosts, DO tunes, whatever you want, and use the equipment until 6 o'clock. And they don't really allow me to really go and extend that. Remember, before you wrap up here today, the whole week I've dumped out in that shared folder. There are a couple of zip files. There's something on file persona. I think, Ron, you asked about that. I put some stuff out there for the EMC to 3PAR online import, dedupe, a couple of things out there. So remember, save that, anything out there, save those before you log off today. And when you're done for the day, if you wouldn't mind exiting the classroom or go offline when you're done. I'm going to be sticking around here most of the afternoon, so if you have any follow-up questions,